Everybody, wanted to spend a little bit of time with you talking about volume, defining volume, and doing some conversions to set up how the ideal gas law works. But before we get into the ideal gas law, we have to know a little bit about volume. So volume is the space that molecules occupy. Now, I get it that a lot of you kind of probably have taken math class, and you probably know that objects have a volume. You take the length, width, height, multiply it if it's a cube. Okay. For gases, we put gases in balloons, so you can find the volume of a sphere, 4/3 pi r cubed. Okay, so there's all sorts of things, but the idea here is that volume is just the space that the gas molecules occupy, and so this balloon is bigger in volume than this cube, or that weird shaped thing that I drew that's supposed to be a cube. Okay, and so it's just that space. And so in chemistry, we symbolize volume with a V, and I think most science disciplines do. And so it's symbolized with a V, and we always use the liter as the kind of the unit to measure volume. Maybe better to say that we use liter in order to do ideal gas law calculations. Okay, so the most common unit that we use to measure things in the lab, though, is milliliters. So we have to be able to convert between milliliters and liters. But I will tell you that any metric conversion is really applicable here in terms of getting from milliliters to liters, or deciliters to liters, or kiloliters, or whatever. But milliliters is by far the most popular one. Okay, so here's some sample problems. Okay, so let's set this up. So we want to go from liters to milliliters. So we write the number that we start with. Okay, 12. Oh, look, I screwed that up already. Okay, and so we have 12 liters, and we're going to set up an X line. That's not me, that's my neighbor next door, colleague next door in the room that teaches next to me. Okay, but the process is still the same as everybody else. Okay, so you put liter is the unit we have. We want to get rid of it, so that goes on the bottom. Milliliters on top, and then we can go, let's see, 1 liter is equal to 1,000 milliliters. Now, I don't need my calculator. 12 times 1,000 is 12,000 milliliters. Okay? Now, we're going from liters to milliliters. We're going the other way. Oh, no, we're going the same way. Look at that. Here's a small number. Okay, liters. Again, we X line. Okay, we put liters on the bottom, milliliters on top. Every 1 liter is 1,000 milliliters. Okay, we get that conversion factor from the previous page or from metric conversions, and now we have 765 milliliters. Okay, now here's the ones that kind of apply to gas law problems, because typically milliliters, if it's not already in liters, milliliters is by far, like I said, by far the most common unit. So we're going to take 368 milliliters, and again, we're going to X line it because we're going to try to convert it. We're going to put milliliters on the bottom and liters on the top, and every 1 liter, just like in all these other ones, equals 1,000 milliliters. And again, I don't need my calculator to do this, but you can get out your calculator if you need it. It's 0.368 liters. So what we've done is effectively move the decimal point over 1, 2, 3 spots. 1, 2, 3. It was here. It is now here. Okay. Notice I will always put a leading 0 in there, though. Okay. And that's, I think, kind of scientifically important. Okay, let's see. Next one, 5.92 milliliters. Again, X line, 1 liter for every 1,000 milliliters. And I do it this way again because I want milliliters on the top, milliliters on the bottom, so they cancel. And now divide by 1,000. So again, we're going to move the decimal point over 3 spots, 0.00592. and that unit is liters. Okay, so that's how to convert numbers into liters from milliliters, and hopefully you have fun doing that.